Hello, everybody, and welcome to our Tasking Live webinar, How to Develop an AUTOSAR Compliant AURIX Application. Today's part number 2 with the focus on performance optimization. My name is Florian Süßmeier, and I'm Product Marketing Manager at Tasking, and I will be the moderator of today's webinar. During our last webinar, part 1, our FAE, Roger Smith, introduced the main features of the Tasking Tricore VX toolset and showed you how you can overcome the challenges of developing a multi-core safety application using different AURIX variants with multiple AURIX cores. In today's second part of the webinar series, our field application engineer Mohamed Suher will guide you through the Tasking performance optimization tools and show you how you can improve the operating efficiency of your embedded AURIX safety application. We are active partners with leading OEMs and tier ones, and our focus is safety critical software development on multi-core architectures. Tasking provides a complete development environment that allows software engineers to develop reliable, safe, and high-performance applications. We are active in regards to the software development V-cycle and provide tools that can be used in different stages. Here you can see an overview of our product portfolio. For software development, for example, we are offering the Tasking VX toolset, consisting of a compiler, linker, locator, and a simulation debugger developed according to ASPICE Level 2 and also TÜV certified according to ISO 26262 up to ASIL-D. In addition, with the latest qualification kit, Tasking is now also supporting the IEC 61508 up to SIL 4 for industrial applications. Supplementary, Tasking is offering LAPAC performance libraries and qualified C libraries as per ISO 26262. The Tasking embedded profiler and the multi-core performance tool support part of the integration testing. In addition, we offer a static analysis tool, the Tasking safety checker, to ensure freedom from interference. And for hardware configuration, the Tasking pin mapper completes the portfolio. The webinar of today will be recorded and will be provided on our website afterwards. You can see here a link. You can also easily go to tasking.com and then go to the resource page, and you can see an overview of all recorded webinars of the past. You will also get an email after the webinar with the link. Let me introduce today's speaker, Mohamed Suher. He's an electrics engineer with over 12 years of industry in developing, testing in automotive electronics. He worked for various functional safety compilers, supporting OEMs, tier ones, customers in automotive semiconductors, and currently Mohamed is working as a field application engineer for Tasking, supporting a wide range of customers for the India region. His area of interest is on the multi-core with focus on safety and security in the automotive domain. Before I hand over to Suher, if there are any questions during the presentation, feel free to use the chat function or the question feature, and we will be happy to take time after Suher is finished with his presentation and to answer all of the questions. Now I will hand over to Suher, and we can start with the presentation.
Thank you, Florian. Thank you for the kind introduction. Thank you all for joining today's webinar. Good morning, good afternoon, good evening. So in the first part of the 3 series webinar, my colleague, Mr. Roger Smith, has given the complete idea how Tasking products can help you for the software development on the AURIX platform. What you see in this slide is a modern day car. So it has many ECUs. So these ECUs are monitoring and facilitating the proper functioning of the mechanical parts. And these ECUs are running a very complex algorithm and exchanging information to make sure that the car as a system is functioning properly. The state of the art is to include a proper hardware and software for this safety critical EPS ECU and to make sure it is a fail safe. For example, if there is a malfunctioning on the EPS ECU or a braking ECUs or a airbag ECUs, this could be a fatal to a passenger. To implement this complex algorithm and redundant calculation in compliance to the AURIX, so AUTOSAR standard, sometimes it leads to an unforeseen, this could be a resource issue. This webinar focuses on performance optimization, and I will demonstrate how you can achieve a performance optimization by making use of a tasking optimization tools as well as the compiler. I will try to recap the previous part of this 3 series webinar. My colleague, Mr. Roger, has given the complete knowledge how you can develop and deploy a safety critical EPS ECUs by making use of our tasking products. And also, he mentioned you in detail and how tasking can be a one-stop shop solution for the AURIX development. In this webinar, I will be concentrating more on the MCPT, which is a multi-core performance tool, as well as the embedded profiler. Okay. And also, I will demonstrate how you can reduce the core load for the AURIX TC27 microcontroller. So by means of multi-core performance tool, you can measure the CPU load as well as the auto task scheduling. And by means of embedded profiler, you can able to identify the CPU stalls as well as the data cache miss. Okay, the customer requirement is already mentioned in the first part of our webinar. So we have a tier one, so who was developing a safety critical EPS ECU, and they are making use of a AURIX TC29X microcontroller. They are in the beta phase, so in order to win a project from the OEM has given a clear specification that core 0 and core 1 will be using by the tier 1 for the usage, and core 2 will be using by the OEM for developing their ADAS application. Tier 1 was trying to integrate their application source code along with Infineon MCAL as well as the Vector BSW stack. In the meantime, what happened? OEM has changed the specification in order to reduce the current consumption. Initially, they want to release the vehicle in the low-cost BRIC market, which is Brazil, Russia, India, and China. And even they want to reduce the cost of the ECU. And they had instructed the tier 1 to change the variant from a TC29X to a TC27X microcontroller. If you see a specification of a AURIX TC27X microcontroller, it is a tri-core microcontroller with core 0 being the efficiency core, which consumes 30% less current. Obviously, the performance of the core 0 is also reduced by 30%. And TC27X is having a 4 MB flash when compared to TC29X, which is having 8 MB flash. And TC27X is having a 472 KB of RAM when compared to TC29, which is having a 728 KB of RAM. Okay. And also OEM has given a strict instruction that it can accept up to a maximum load of 65% on each core, which is available to tier 1. So now, what all the software we develop using the TC29X has to be ported to a TC27X microcontroller, and the condition is we have to make use of the same tool set for all these developments. Okay, we'll see how we can do this. So in this webinar, so I will be making use of this embedded profiler as well as a multi-core performance tool, which are all the two top class optimization tools. By means of embedded profiler, you can able to perform 3 types of analysis. One is a performance analysis, where you can able to identify the performance hotspots such as a CPU clock count, CPU stalls. And by means of a memory analysis, you can able to identify the instruction cache miss, data cache miss, memory conflicts, memory access, etc. And the same way, so by means of a functional analysis, you can able to analyze the function call as well as the function returns. By multi-core performance tool, you can able to perform core load analysis. So this type of analysis will help you to visualize your data in minimum, average, as well as the maximum core load. And by means of a AUTOS analysis, you can able to analyze task activation, task execution time, interrupt execution time, etc. Even for example, if you are in the decision-making phase and you are evaluating the multiple OSEC real-time operating system, you can make use of our tool, multi-core performance tool, for the core load analysis without modifying your embedded application code. Both the tools are very easy to use. Just you need to provide the application L file to this tasking performance tool. And after that, you can do a analysis, profiling, as well as you can do analysis on the multi-core performance tool. So this method is a purely a hardware driven method. It is not a software driven. And if you are making use of an application kit, just a normal USB cable is enough. And if you are making use of any of the custom board, then you need to make use of a mini wiggler, which is a low-cost debugger available with the Infineon. So both the tools, embedded profiler and multi-core performance tool, is specific for AURIX microcontroller. So with the type, so MCDS, whether it may be a mini MCDS or it may be a MCDS Lite. Okay, MCDS uses a emulation devices, and emulation devices as an emulation extension chip, which is also available on the same silicon. Okay, if you see that is accessible through a JTAG or a DAP. Okay, so what we do now, so we now ported the code which has been developed for TC29X to a TC27X microcontroller, which is a requirement from the OEM. So we ran the tool, we ran the multi-core performance tool. What we saw in this multi-core performance tool, the core one is overloaded with 81%. So we need to optimize the code in order to meet the OEM requirement, which is 65%. Okay. The optimization is a iterative process, so it's a routine process. So we need to keep on doing some kind of optimization. Okay. So we can see how you can able to identify by means of embedded profiler, and also we can see how you can change some of the compiler options in order to reduce this core load. So with embedded profiler, so you can able to locate the stalls as well as the data cache misses. So whenever the CPU stalls occurs, it eats up the precious CPU time and increases the core load. So whenever the stalls occur, so stalls are commonly caused by cross-core memory access. So if you see on the right hand side, if you see a small diagram, you can see if you have a multiple cores and that are trying to access a shared memory resources and which are connected by means of a shared interconnect bus. And for example, if CPU1 is trying to update a data in the DSPR2 of core 2, then the shared interconnect bus is clogged and the CPU1 will be stalled. And the same way, if you see, if you have a multi-core, so CPUs, which are trying to read and write to a local memory unit, which is a slower memory, and it is just waiting for the data and it is doing nothing, which can also lead to a memory stalls. And data cache miss is also one of the important contributing factor which increases the core load. So we need to identify the stalls as well as we need to reduce the data cache miss. And also we can see whether we need to really see on the compiler options also, whether we need to change the compiler option also in order to reduce the core load. Okay, before we perform the profiling, so we need to understand the internals of the EPS ECU, what we have here. In EPS ECU, the core one is used for reading the sensor information and the motor control algorithm is implemented on the core one. And we are using the Erica Enterprise Autos in order to realize the real-time behavior of the system. Okay. Even if you want to know more in detail on each of these specific products, multi-core performance tool and embedded profiler, we also have a recorded webinar available on our website. You can get more in detail on these specific products. So I had done a profiling on the embedded profiler. So what I saw in the embedded profiler results is you can see in the performance analysis window, so there are a large number of cross-core memory access. And CPU 1 is trying to read the sensor information from the DSPR0 of core 0. And parallelly, it is trying to update an array or a data on a DSPR2 of core 2. So because of that, you can see large number of cross-core memory access, which are highlighted in red color. And even you can also see, so which are all the major functions which consumes most of the CPU clock count. So I have a lot of functions available. If you see the function on the left-hand side, the function 1 millisecond task consumes almost 2 million CPU clock count. And I have another function of 5 millisecond task, which consumes almost 400,000 CPU clock count. And if you see a memory analysis window, you can see which are all the major functions which contributes most to the data cache misses. So by this way, you can have a complete analysis about the stalls and about the complete data cache misses. So what I will do now, I will try to optimize the function 5 millisecond task. And once if I double click on this, on the performance analysis window, if I double click on this function 5 millisecond task, it will take me to the source code on the embedded profiler for this function 5 millisecond task. And what you can see here on these 2 lines of code, you can see major number of stalls. One is a for loop. So where the CPU core 1 is trying to read the sensor information from the DSPR0 of core 0. And we have a motor control array, which is trying to update the data, where the CPU core 1 is trying to update the data on the DSPR2 of core 2. And on the right hand side, you can see, so there's also a memory access window where you can have a complete detail. What is the exact function and what is a variable? What is a variable you had given the name, and what is the region which is trying, whether it's trying to read the data, whether it's trying to write the data. All these things you can able to analyze by means of this memory access window. And in fact, you can also see the origin CPU. So CPU 1 is trying to write the data on the DSPR2 of a core 2. Because of this, you can see, so there are a large number of stalls occurring on this particular line of code. So we have to fix these stalls on these particular lines of code. So let's fix these stalls. So we have to move this information from the CPU core 0 as well as from the DSPR2 of core 2 to a, on the DSPR1 of core 1, which is a own data scratch pad register. Okay, and also one of the important things, you can also able to find the memory conflicts, where for example, if 2 variables from a different core trying to access the same memory at the same time, at that time you can able to judge whether it's a intended or it's a software bug. So by this way, you can able to have a complete analysis on the memory access tab, as well as on the memory conflicts tab, as well as on the, and if you want to know more in detail on the disassembly part, you can go more into that. And once if you click on the summary tab, you can have a full in detail about all the functions. Okay. So as I already mentioned, data cache is one of the important contributing factor which increases the CPU core load. So data cache misses normally occurs when you are trying to read or write a large array, and if the size of the array is greater than the data cache size. And what you can see on the right hand side, I have a small code snippet taken from my project. I have a buffer size of 8 KB, and I'm trying to update an array of a data cache size which is just having a 4 KB. And because of this, obviously there will be a large number of data cache miss. And how you can reduce that? It is very simple. I will show you. Just you need to divide this array into multiple chunks. And I'm trying to divide this array into multiple chunks and update the innermost part of the loop, which will be 1/4 of the data cache size. So by this way, you can completely avoid the data cache misses. So what we had done initially, so we ran the tool again in multi-core performance tool. We can able to see that the core has been reduced from 81% to a 70%. Still, we need to reduce the core load by 70%. So we ran the core load analysis by means of a multi-core performance tool. And by means of embedded profiler, we can able to locate the stalls as well as a data cache miss. And we can able to see the core load has been reduced from 81% to 70%. So we can see whether we can able to do some kind of a compiler optimization option in order to meet the OEM requirement. Tasking offers many compiler options to optimize performance and code size. So our main target is here to increase the performance gain as we have enough flash size available on our microcontroller. So if you see the tasking optimization options, it is having an optimization options available from O0 to O3, where O3 is the highest optimization level. So these optimizations is a combination of individual optimization, which we are calling that one as a custom optimization. I will show you in the coming slide what all the custom optimization. So O3 is the highest optimization level where the code is optimized for high performance and least code size. And O2 is a default optimization level. And we always recommended for every software engineer to make use of the optimization O1 for the debugging. Why? Because the code which has been generated with this debugging can easily be correlated with the source code, and it is easy for the software developer to debug. And once if you make use of the highest optimization along with the trade-off factor T0, then obviously it will be difficult for the software developer to debug. And obviously this optimization has to be used in combination with the trade-off factor. And if you see the trade-off factor, T0 is for the high performance code and T4 is for the least code size. Okay. So what I'm going to do now, I'm going to make use of the optimization O3 along with the trade-off factor as my main aim is to increase the performance gain. But before going to this optimization with the trade-off factor, I will show you where you can select this optimization. You need to right click on your project and you need to go to the properties and where you can see the optimization level. O0 is for none and O3 is the most optimized one. And the same way, below the optimization level, you can see the trade-off between the speed and size, where the level 0 is for the speed one and level 4 is for the size one. Even for example, if you want to make use of a custom optimization, if you want to enable or disable some of the custom optimization functions, you have an option to do that also. For example, if you want to enable the loop unrolling, or if you want to enable the automatic function inlining, where most of the small functions are not oftenly called, then it will get discarded automatically. So by this way, you can have a complete custom optimization also, whatever the things which is applicable for your application source code, you can enable and disable that, disable by means of a custom optimization. Okay. And still, for example, even if you have a complete project where you have a combination of subfolders, like for example, if you have a device driver folder, and if you want to apply a different kind of optimization and trade-off for this main project as well as for the device driver folder, you can still do that one by means of a tasking options. I will show you here. I have selected for a main project. For my main project, I have selected a trade-off factor level 3 here. And for my device driver, I have selected a trade-off factor on the level 4, which is a size 1. By making use of this option, you can able to select a different trade-off as well as the optimization level for various subfolders on your application project. So by means of a multi-core performance tool, so I can able to analyze the core load. By means of embedded profiler, I can able to locate the stalls as well as a data cache miss. And by means of a compiler options, I had changed the compiler options with the optimization O3 and with that of a trade-off factor T0. So what then I ran that tool again in the multi-core performance tool. What I saw is I can able to reduce the core load from 81% to a 65%, which I can able to meet the OEM requirement. You can see from an unbalanced core load, so I can able to do a core load balance for both the cores. So you can see I had changed the compiler options if I have no choice to do. Only if I have no choice to do, I had changed the compiler options. So once if you change the compiler options, so sometimes you may face the consequences. So why you will face consequences? Why? Because so the MCALs and BSWs are qualified and tested with a set of compiler options, which will already be mentioned in the release notes. If you use the optimization O3, and if you're trying to integrate with your MCAL and BSW with the optimization O2, then the code as well as the hex file generated with this optimization will be different, and you will lose warranty on the MCAL. Obviously, modifying compiler optimization may impact your ASIL qualification. So this is not the end of the world. You can check with the MCAL and BSW vendors whether they are ready to change the compiler options with a nominal fee. Before you select on this optimization, you need to make sure that the cost associated in changing the compiler options of this MCAL and BSW with the cost associated in selecting the microcontroller with a higher capacity. So you have to make up your mind clearly that between these two. Okay, the OEM was really happy with the tier 1 performance, and they had awarded the project to the tier 1, and the tier 1 was really excited with our tasking optimization tool, and they want to show us whether we have any kind of a benchmarking. Why? Because there are a lot of competitor tools which also provide same kind of a optimization. So for that, we want to present this benchmarking slide. So these are EMBC benchmarking, which is a performance benchmarking for a tasking CTC compiler with a C2 compiler. So these are performance benchmarking where the application is executed in order to get the least code size. And okay, if you see most of the modules, so tasking is always better than the competitor. Okay, if you see most of the modules, so it has been sampled for a embedded automotive application. And if you see one of the module EMBC.A2 time, it is a angular to time in order to calculate the angular velocity of the crankshaft. And once if you see the overall performance, tasking compiler is always better. Okay, and once if you see in some of the module like EMBC.can RDR, where so C2 compilers overperforms a tasking CTC compiler. But still the tasking produces a 50% less code size for this particular module. And once if you do a deeper analysis and if you do some kind of a research on this particular module, what we saw here is in these cases, the C2 compiler is making use of a loop unrolling. So we need to understand what exactly is a loop unrolling. Okay, here what you see in this slide, I have a for loop which is incremented 4 times, and I am just updating the status variable. And on the right hand side, I took the result from the embedded profiler. So with the optimization O0 with no loop unrolling, so the ASM code which has been generated with this optimization, you can see so there is a move instruction, there is a jump instruction, there is a add and load instruction. And the same code with the optimization O3 with loop unrolling, you can see the ASM code which has been generated with this loop unrolling. And the conditional jump has been replaced by a move, add, as well as a load and store instruction. And this code is almost twice or thrice time with that of a no loop unrolling code. And the main idea of presenting this benchmarking is that most of the customer who were making use of the C2 compiler come back to us with a common complaint is that the code which has been generated on making use of the competitor compiler is so large that it cannot fit into the microcontroller. So they need to make use of the higher microcontroller with a high flash size. So what is the point of increasing the performance gain if you don't have enough flash size available for your microcontroller? So the key takeaway from this slide is there is no ideal compiler. So you need to select a compiler with a decent trade-off in performance and code size. So mistakes in choosing a wrong compiler will cost you a lot of money in the long run. So you need to make sure that you selected a correct compiler for your application source code. Okay, then tier one was really happy with the benchmarking result, what we provided with our competitor tool with the C2 compiler. And they got convinced with our benchmarking result. And still they want to know whether any other advantage whether the tasking compiler offer. Why? Because though there is a significant delay between the release of a latest version of the compiler with the MCALs and BSW tested and qualified with this latest version of the compiler. So the tier one and the OEM always wanted to make use of the latest version of the compiler because of the latest features available in the newer releases. Since MCALs and BSWs are qualified and tested with the older version of the compiler, so they are also forced to make use of the tier one, and the OEM also forced to make use of the older version of the compiler. Okay, so in order to get rid of that, so tasking has a capability in our compiler where we are calling that one as a cross-linking capability, or we are calling that one as a cross-linking feature. Okay, this cross-linking feature allows you to link software modules compiled with two different compiler versions. So we want to provide our customers with the option of using the latest compiler list and still be able to combine their software with other software modules, so compiled with the older version of the compiler. Okay. And tasking guarantees that, so the object files which has been developed with the lower versions like a version 4.2 R2, version 5.0 R2, or version 6.0 R1, or version 6.1 R1 can be linked to version 6.3 R1 object files. Okay, so consider, so these are one of the example scenario where you have a MCAL which has been developed with the version, so CTC version 4.2, and you have an application along with the BSW which has been compiled with the version 6.3. So these two can be linked and you can generate a corresponding L file. Okay, so the cross-linking is available from the version 4.2 or 2 onwards, where it is also a MCAL version. Even for example, if you are working on a SIL-D project, the cross-linking can also be certified. If you are interested in the certification, so we request you to get in touch with us, so we will support you on that. Even for example, if you are working with the older version other than 4.2 or 2, so cross-linking can also be offered as a service. So in that type of situation, you can just get in check with us. So by this way, so you can make use of the cross-linking features where we are allowing all our customers to make use of the latest compiler release so that they can combine, they can combine their software with other party software which are compiled with the older version of the compiler. So tier one was again really happy with this particular feature. And these are the common questions we used to get it from our customers, tier one, as well as from the OEM. Whether the tasking tool support software over the air updates. Why? Because most of the vehicle manufacturers nowadays wants to fix downloads and provides updates from a cloud-based server. And even they want to run their flash routines from a RAM. Can tasking be of any help? Yes, we do have a mod. So we do have a feature in our tasking compiler, which we are calling as a position independent module, which can be loaded and executed from an arbitrary memory location. So in that we have a position independent code as well as position independent data for the ROM and RAM data objects, which can be generated using a tasking compiler. Okay, and this PIC, which is a position independent code as well as a position independent data, and both these base address are configurable. So by this way, so you can make use of this software over the air updates also, and even you can run your flash routines from the RAM. So by making use of these tasking features. Okay, and if I want to see the wrap up on this particular webinar, so you can see, so I had make use of a multi-core performance tool where I can able to accurately measure the CPU core load for the CPU 0 as well as for the CPU core 1. And by means of the embedded profiler, I can able to identify the stall as well as the data cache errors. And so we can able to demonstrate the code and how it can be easily ported from a higher microcontroller to a lower microcontroller with a low flash size with a lower RAM. So by this way, we had fixed our stalls and we can able to identify the data cache misses, and we can able to successfully port the code from a higher variant of a microcontroller to a lower variant of the AURIX microcontroller. And later we saw so how you can select a tasking compiler optimization options and how you can change the compiler optimization option. So in order to provide a optimal trade-off between a performance and code size. Okay, and last but not the least, so we also saw how you can able to make use of the cross-linking feature available with the tasking compiler. So with this cross-linking feature, so you can able to work with the latest compiler release, and still you can able to combine your other third-party software developed with the older version. And you can able to locate the object files into a specific memory regions by making use of a position independent modules. So which can be loaded and executed from a on arbitrary memory location. So finally, you agree that so tasking is a one-stop shop solution for the AURIX development. Okay. And this is the last slide. So where I want to show you, we also have a new feature available in our latest version of our embedded profiler. If you want to know more in detail about the so direct memory access load, you can make use of this so DMA load analysis feature on our embedded profiler tool. And in fact, so if you see on the bottom of the snapshot, the DMA channel load part of the summary tab, which shows the DMA load percentage for the topmost DMA channel. So by this way, you can have a complete analysis for all the channels of your so on the direct memory access, and still you can able to see the complete summary of your DMA with the DMA load timeline as well as the raw trace data. So that's it from my side. So
Thank
Florian,
you.
I'll hand over to you.
Thank you, Suher, for your presentation. And thank you everybody for joining this webinar on performance optimization. We would also like to invite you to join our next upcoming webinar, the last part of this three-part webinar series, which will take place on April 15th, which will be actually then the concluding part of this three-part webinar series on how to develop an AUTOSAR compliant AURIX application. The final webinar will focus mainly on safety aspects. In this webinar, our FAE will then showcase the tasking safety checker, a static analysis tool that can help you to guarantee freedom from interference of software modules. He will also be then introducing the compiler qualification kit, the functional safety work products that can help you certify your application up to ASLD level. So let's see and also before we start the Q&A session, there are a few questions I can see already. I would like you to also encourage you if you would like to have a free evaluation, a license for any of our performance tools, embedded profiler or multi-core performance tool, just drop us an email at sales@tasking.com and we will get back to you. You can also follow us on LinkedIn to get the latest news from tasking. All right, so now let's see and have a look at the questions. So there's one question, could the access on the system RAM cause stalls?
Could the access on?
So maybe I can try to answer. So Bharat Kopa here, another FAE. I think with system RAM, you are referring to the LMU on the Infineon. So of course, this will cause stalls when you try to access a variable, write or read a variable from the LMU, because this is also something that is connected to the shared interconnect bus.
Okay, thank you, Bharat. Then there was another question, emulation extension chip. This means that the performance tool can be used only on the TC XX derivatives, which have emulation extension options. And I think, Bharat, you answered this already in the chat. So
yes, so
maybe you can repeat for everybody.
Sure. So, so if you are using an emulation device, then it has emulation memory. But you can use embedded profiler and MCPT tool with devices that support MCDS and also mini MCDS. But if you want to run a performance analysis, where you want to locate stalls and cross-core memory accesses and everything, so we recommend that you use an emulation device that you have enough sufficient emulation memory.
Mm-hmm. Yeah, thank you. Any other questions from the audience? There's another question popping up here. How can you use the compiler trade-off factors to minimize the generated code size?
Okay, so I will answer this. If you see the compiler options, and once if you right click on your project and if you go to the properties section, where you can see you have an optimization options, where on the below the optimization level you have the trade-off section. By this way you can select the trade-off factor.
Mm-hmm. Thank you. Any other questions from the audience? We still have some time, so feel free to ask. There's another question from a user. Hello, it would be great to get some information on use of flash cache and no cache. This was pretty much at the beginning of the session.
Yeah, it would be great to get some information on use of flash.
Yes, this is a
Cache.
more general question.
Yeah. So let me. So we have another webinar that's planned that would be coming up in the second half of this year, and this would go much more in detail regarding the cache, the program, the P cache and the D cache. But just to answer your question, so if you think that you have a cache miss or a data cache or a program a flash cache miss, that could also be detected using the embedded profiler. So when you run profiling, then it will show you if you have some data cache or P flash misses.
Mm-hmm. Thank you, Bharat, for answering this question. Okay, so it seems like there are no further questions coming in.
And I can see one more, Florian. So emulation
Yes.
extension chip, this means that performance tool can be used only for the TC XX derivatives which have emulation extension option, I guess. Bharat has already.
Yes,
Yeah,
this
okay.
one has already
Yeah,
been answered.
yeah.
Mm-hmm.
Thank you.
Okay, so if there are no further questions, I think we can close the webinar. I really encourage you again, if you are interested in any free evaluation license of our tools, any tools, embedded profiler, which has been mentioned today, or the multi-core performance tool, or you are interested in a free evaluation version of our compiler or any other products, feel free to drop us an email and we will get back to you.
Okay, so
There's
there are
one
some
question. Yeah, there are some questions now coming in. For how long is this available, a free evaluation? evaluation license. So normally the evaluation license is valid for 30 days, but we have also different kind of licenses which we can provide to you. Any other questions? No. Okay, so then we will send you an email directly after the webinar later today or tomorrow morning with the link to the recording. And if there's any other questions after the session has been closed, feel free also to drop us an email at sales@tasking.com. Okay, thank you very much, Suher and Badat, for presenting today. And then we see you all in 4 weeks' time on April 15th for the last part on tasking safety products. Thank you very much for joining.
Okay, thank you.
Thank you.
Thank you all for joining.